Captain, she's breaking up! Because we've got 99 tabs open, there's a coronal mass ejection watch, and this eye patch doesn't help. I may have to go in the hold of a ship. Oh my god, let's hope not. This is the daily space weather, and we've got a coronal mass ejection watch in place here because of this. It's highly likely to produce a coronal mass ejection sort of in the Earth-facing vicinity. And if you're a new viewer to the channel, realize that we only forecast coronal mass ejections in approximately this area. We don't do this area. We do this area. Now this view here is from Stereo A's coronagraph. So again, if you're a new viewer, realize Stereo A is located there at Lagrangian point 5. Here's a viewpoint from Lagrange point 1. This is SOHO's LASCO C2. And a similar type of coronagraph here, located right between the Earth and Sun at Lagrangian point 1. The gravitational equilibrium point right between the Earth and the Sun, about 1 million miles away. So at noontime, it's sort of not directly overhead. Well, it might be directly overhead if you're on the equator, right? Here's some more imagery of the Sun itself. And this is actually 304 angstroms here from the Solar Dynamics Observatory. And you can see some of the filaments here. Here's a filament. There's a filament up here. There's one down here. Quite a bit we'll show you at the end, the hydrogen alpha imagery from our ground-based observatories. And let's zoom out here so you can see the time and date stamps and the polar regions. Great imagery there from the SDO. Yowzers. And here's some more spectacular imagery of the closest star from SDO in ionized iron, 94, 193, and 335 angstroms. And we'll get to the solar flare data and so on in a moment. Here's another composite image. Series of images, really. Stitched together on the convenient browse data portion of the SDO website. And the cool part about the SDO browse data is you can just rock it back and forth like this. If a flare happens, like you can see this small flaring event from right over here, that's not even a sunspot, folks. And keep in mind that we see coronal mass ejections all the time with no flares and with no sunspots. So that doesn't affect our ability to forecast them one bit. Let's run through a whole bunch more data because there's lots of stuff to cover. Here's a diagram of the solar system. We'll advance it 1 week. Did you enjoy full moon? That's where things will be in 1 week. The radio flux is, I think it's at 87. Space Weather Enthusiast dashboard usually gives us good information. Oh, down to 84. Okay, so here's the 1-year chart of the radio flux. It's the most proportional data set to sunspot number. And it's dropped because the sunspot number's dropped and the sun emits more radio photons. The sun emits more radio photons when there are less sunspots. Anyway, no solar storms or geomagnetic unrest forecasted by NOAA. There's a massive earthquake drought in effect and an uptick in earthquakes. Please have an earthquake plan if you're in an earthquake-prone zone. And shout out to our athletes in Japan. As, lots of athletes in Japan right now, and it's in the danger zone. We've had a massive drought of 7 magnitude earthquakes. You can see only 1 7 magnitude quake here in the past 90 days. Expect to see a big one soon. I certainly do. Try to be an asset, not a liability. If the buildings start to fall, have an idea which one may start to fall. So first of all, some significant activity here north of New Zealand in the Kermadec Trench. In between New Zealand and Tonga, there's a massive ocean trench. And it's one of the most seismically active areas in the world. Also seeing lots of deep quakes in there, but this one's not. It's only at 7 kilometers. Very close to the surface. Let's hope it's not a foreshock, as that's the kind of quake that can create tsunamis if it's a little bigger than that. So a little bit of an uptick here in activity, but still no major quakes. And again, only one 7 magnitude earthquake in the past 90 days. There was one that was initially reported at a 7 but downgraded, so we'll just take that as it is. I'm not complaining, as the USGS's job is hard. And dealing with cretins on the internet is harder. So there was a 5.4 in Mexico. That looks like it must have caused some damage, as we've got a red here on the Did You Feel It chart. What's up with that? Is it in a highly populated area? Just off the coast there, in between Cabo San Lucas. So, highly populated area, I guess. I don't really see any cities or anything. Oh, that's highly populated. Of course, La Paz right there. Definitely not a Mexican geography expert, this guy. And back to the list here, I'm just going to scroll. There was a deep quake at Fiji at a 4.2 magnitude. And then a deep quake under Mexico at a 5.0 magnitude and over 204 kilometers depth there. Those quakes only happening about 15 minutes apart. More like 26 minutes apart, something like that. Don't make me do math. Don't make me do time math. It's a mess. So here's another one north of New Zealand in the Kermadec Trench, or near the Kermadec Trench, in between New Zealand and Tonga. That trench becomes called the Tongan Trench if you go farther north. And a 5.8 in that region. So that, hopefully those are not foreshocks. Hopefully that 6.1 is not a foreshock. It looks like it might be the large quake. Let's hope. And volcanoes. Once again, shout out to Kurt Begemon. Kurt, come on the channel and do an interview. We'll talk about your experience and share your video and photographs and so on from Fagradalsfjall. Yes, Fagradalsfjall, being visited by a cyclist from South Africa, Kurt Begemon. Make sure you check him out on Instagram. And follow us on Instagram. Also, Instagram.com/smAshomash is the URL for that. Instagram.com/smAshomash. So Karinsky is on the list, but we don't know if it's erupting because it's not identifiable in satellite imagery. And Kamchatka is one desolate place, folks. Not too many people on Kamchatka right now. Semeru, on the Isle of East Java, producing an intermittent eruption. It's only a 14,000-foot plume of volcanic ash. Dukono exploding, flight level 070, with a 7,000-foot ash plume. Fuego in Guatemala exploding, 15,000-foot ash plume there. Nevado del Ruiz, volcanic ash not observed. Don't assume it's not exploding. It could be fertilizing the downwind regions for some excellent farming in the coming weeks and years. Sangay exploding. Volcanic ash plume reached an altitude of 20,000 feet over Ecuador. Sabancaya exploding over Peru. 20,000-foot ash plume there as well. And we're unable to detect Nevados de Chilean. Please don't pole vault the caldera. It could be unhealthful. And we need the views on YouTube. So, and also, you should pick up some merch. We've just added all kinds of additional merch here on the Redbubble shop. If you go to smashomash.com, you can find a link to it right there. Click on SmAsho merch. It'll take you here to the Redbubble shop. And so we've added the Mensa and the Mansa products. Today's featured product is the Do Not Pole Vault the Caldera leggings. I'm currently wearing the Do Not Pole Vault the Caldera socks. And there you go. It's it's good times. It's good times. Do not be like Steve Stimpak and die in a tragic table tennis accident. Do not pole vault the caldera. Steve Stimpak didn't want the kids pole vaulting the caldera, so don't you do it either. This public service message brought to you at massive personal risk and expense smAsho.com. Please give smAsho staff a raise by picking up some merch, or perhaps becoming a patron, or perhaps allowing us to build your website. So let's look at the GOES 16 instruments here. Here's the X-ray flux over the past 3 days. No major flares. And we don't expect any major flares here as we're moving into the Earth-facing quiet effect, which is caused by the way the sun emits photons. Are you familiar with limb brightening? You know why the sun appears brighter at the limb in X-ray frequencies? We'll get into it in a later video, like a cosmology segment. No spikes in the proton flux, no CMEs on Earth's way at the moment. GOES magnetometer, there's a 3-day chart, and you can see these little sawtooth areas. Those are the current sheet having a little tug of war. There's a little bit of a North Pole, South Pole polarity battle happening with the plasma out there, as the sun is indecisive as to which current sheet is currently charging up the earthly plasma, and this affects the fields and the detection of the fields in like totally different ways. Anyway, you can see the current sheet here. There is a South Pole polarity region coming, so we can expect to see like a bunch of sawtooth patterns here in the GOES magnetometer because of this data here, the top view ecliptic plane field plot. Tells us a great deal about what the GOES magnetometer will do in the coming days. Once again, if you're interested in how we forecast coronal mass ejections, we've got to write a scientific paper about it before we make a YouTube video about it. There'll be supporting material together. Here's a line of sight coronal, not the line of sight coronal plot, the line of sight ecliptic plane field plot, a plot of magnetic fields. And this is all based on ground-based magnetometers and magnetometers on stereo A and stereo B. That's where the data comes from. And you can see that little tug-of-war going on there to our east, out in this area. Oh, indeed it is that area, but I meant this area. You see that blue line swinging around? That's the little magnetic battle that's going on. It's not really a battle, it's just the current sheet has both polarities in it, and that affects the detection of the magnetism. Here's the coronal hole line of sight plot. It shows you the sun's B field in blue. And by the way, the sun's B field appears to be the extent to which this field and this field overlap each other. And you can see some progression of solar cycle 25 right now. There is a trans-equatorial coronal hole system here, but it's looking very weak. And by the way, this is what a terminator event looks like. For all of you advanced viewers who know what a terminator event is, a terminator event is when the solar cycle stalls and then goes into hyperactivity mode. We would expect to see some hazy polarity coronal holes when that happens. Not a sunspot or anything like that. We would expect to see a buildup of intercalate gases, probably. And by the way, this sort of theory does support my solar model and explanation of the solar polar field reversal cycles. So here's our flare monitor. And yeah, it's the likelihood of flares has dropped both because of the degradation of sunspots and because of their location. When sunspots move into this zone right here, they're much less likely to produce large flares. And when they're in these zones, they're much more likely to produce large flares. And it all has to do with the emissivity of metals and black body radiation and the idea that the sun is probably not comprised of a gaseous plasma, but of condensed matter. It supports all of this. And shout out to Eugene Bagashov for doing some recent science about the location of large solar flares. KP index currently at 1. And yeah, it's only been at 1 or 0 here for the past 21 hours. So very weak solar wind coming in, and let's take a look at it. Weak solar wind, weak magnetosphere, not a lot of induced magnetism from incoming solar protons. Low levels of Bremsstrahlung. Yes, Bremsstrahlung. And if you're wondering what that means the breaking radiation. So one of the things that happens when solar protons are slowed down by Earth's magnetosphere is that they emit radiation as they're forced to suddenly change direction and speed and so on, and all kinds of things happen. One of them is radiation gets emitted, and that's part of the Earth's geospace. We can't get into the physics. It's the daily space weather video. Anyway, here's the real-time solar wind, and this is wow, we've seen very diffuse solar wind. Now, this is a little bit of suspect-looking data here. This could be a tiny coronal mass ejection strike. So this is what we would expect to see: a signal in the speed, a signal in the plasma temperature, which is this green bar at the bottom, and then a slight change in the density and a slight shift in the phi angle. That's all. That's consistent with what you'd see with a weak coronal mass ejection. Tiny little uptick in the speed there, and a downtick in the density. So that's a thing that can happen too. Sometimes. Yeah. Anyway, it looks like a coronal mass ejection. Moving on, current conditions are about 3.5 protons per cubic centimeter. Very low solar wind density, and quite low solar wind speed, similar to solar minimum speeds at 342 kilometers a second. Here's the pressure around the geospace. And pardon me if I start talking more quickly. I went to the Ben Shapiro School of Fast Talk. I don't go out of my way to try to jam large words into a sentence. That is what hacks who want to look smart say. They write sentences like Hemingway to try to sound smart. Anyway, here's the magnetohydrodynamic pressure around planet Earth for the last 4 hours. And it all looks like good data today. If you want to see some bad data, go check out yesterday's. It probably had people with their hair on fire running around saying, OMG, we're going to die, we're going to die. Here are ground magnetic perturbations. The last frame was the geospace magnetosphere movie for magnetohydrodynamic pressure. This is magnetism itself in nanotesla on the ground level. Not a lot going on, not a lot of induced magnetism here as a result of incoming solar protons. Perhaps an indirect result. Anyway, that's 4 hours of data. By the way, once again, thank you for watching the content, and congratulations on realizing our channel exists. We're fairly sure the algorithms dislike us, so feel free to share the content on your social media. Tell your friends and foes, science noobs and science pros about it. We're also on BitChute, by the way. And there's exclusive content there if you haven't seen the 500 subscriber special. All I got to say is, we are alt tech. That's why we built smAshomash.com. Thanks to our Twitch followers as well. Twitch.tv/smAshomash will actually be streaming live today for our cosmology segment. So make sure you check that out. It'll be a separate video as it's lengthy. It's part of the 99 tabs that we have open. We've got 99 tabs, but a cosmology segment ain't one. It's several. That was a good one. If you haven't checked out our cosmology segments playlist, head to youtube.com/smAshomash/playlists and check it out. We're pushing 220 videos in our cosmology segments. Next, looking at the electron flux surrounding planet Earth. No charging hazards currently. And we did see a little higher levels than NOAA forecasted. Here's the 1-year chart as reported by Solon.info. Can we make it bigger? Oh, yeah. Oh yeah. And here's the 3-day chart. Seeing the highest levels that we've seen here just recently coming in the past 3 days. So they're moving into higher and higher levels here. I wouldn't be surprised to see us flirt with or possibly cross the threshold here of 1,000 pulse flux units and end up in warning territory. Although it's not going to be super high, it was about what we forecasted yesterday. I would expect similar to slightly higher levels coming today. And back to the 3-day chart here. For you new viewers, the N's and M's, they mean noon and midnight time for the GOES 16. Here's a diagram of the Van Allen belts to give you an idea of what we're looking at. And here's the total electron content forecast. It's showing you the whole air column all the way up into the thermosphere to tens of thousands of feet of altitude, tens of thousands of miles of altitude for geosynchronous satellites, which are responsible for your GPS. So this will give you some idea of some anomalies, and we do see some anomalies here in the southwestern Indian Ocean, south of Africa, and so on. I'll let it play through a third time here. If you need to watch it again, you'll have to rewind our video, and we apologize for the interface on YouTube. I assure you, we did not build the software. Do not hold us accountable for other people's software writing. Anyway, some significant electron anomalies going on once again here. Here's another diagram of the atmosphere showing you things like solar min versus max temperatures, electromagnetic radiation, and the levels of the ionosphere. We're going to be looking at just one slice, the F ionosphere. Located about 300 kilometers of altitude, we're seeing some anomalies once again. And keep in mind, folks, we are approaching an equinox. The closer you get to an equinox, the more geo-effective every little bit of solar activity becomes. Now, of course, March is actually the most geomagnetic month. I would think October is probably the second most geomagnetic month. And it all has to do with the Bremsstrahlung, once again. Bremsstrahlung. That's a handful, but I took German, so it's pretty second nature to me. Anyway, here's the latest image on the ionosphere, and we're still seeing anomalies here. We can expect more anomalies around this area and around this area in the coming couple of hours. What that means for you is not very much. And I'll have to pause the video for a recording of a live meteorology segment. Make sure you check that out if you haven't seen it. Meteorology segments are also a playlist. youtube.com/smAshomash/playlists. All right, and another spectacular meteorology segment today. Just fantastic. Make sure you check it out if you haven't. We premiered it before our daily space weather video. And here come bonus features. So here's the latest hydrogen alpha imagery, 6,562.8 angstroms from El Teide, Spain. And you can see some of the filaments here that are involved in our coronal mass ejection watch, mainly these and these. Some of these may have already ejected here, folks. I see less filaments than I saw earlier. That's all I can say. I see less filaments. There could be a coronal mass ejection happening as we record the video. And going back to stereo A to see, indeed, there is a little bit of ejecta here coming out. It's still just a coronal mass ejection watch. We'll let you know when it really happens. By the way, if you're wondering what this is, it's Mercury. Here come more bonus features in the form of a freshly refreshed ultra-high-resolution solar intensitygram. And you can see this sunspot has degraded as it faced the Earth. So it's a twofold decrease in likelihood of large solar flares here, folks. And this one in the southern hemisphere, oh, there could be a new one forming, though, so check it out. Here's a new group. I think that's a new group. Or maybe that's an old group that's reformed. I don't know. But here's the solar magnetogram. Again, intensitygram, magnetogram. I think we've only got alpha-class sunspots, so the likelihood of solar flares has dropped significantly. Here's the GO-16 SUVI. And you can see once again on this imagery here that there are lots of filaments between Earth and Sun. There's a North Pole coronal hole stretching down here too, which didn't really show up in the other imagery, and a little bit of crown prominence style stuff happening, but nothing major. Pretty low solar activity overall. All right, and here is one more set of images from the SDO, the Solar Dynamics Observatory. This is ionized iron in 171 angstroms and colorized magnetogram together, all in one. If you want to look this up yourself, go to the data, click on Browse Data. You can put in whatever dates and times you want. You can rock it back and forth. It's spectacular. And once again, congratulations on realizing our channel exists. Keep staring at the sun. Keep staring at our channel. Press like and subscribe if you're new here. Tell your friends and foes about us. Press share on your social media. And may that solar wind be at your back.